Hey everyone! I had a few people ask questions about this type of problem in the normal distribution section of the assessment. So I wanted to do a quick video and share with you how to go about looking at this question. So a lot of people have already gone through the normal distribution on the calculator using the normal CDF. And really for this type of question, we want to look at our empirical rule. So the graph here illustrates a normal distribution for the prices paid for a particular model of HD television. The mean price is $1,000 with a standard deviation of $80. So you see here, our mean is at 1,000. That's our center, and we know it's normal, so we have this nice symmetric bell curve, and each standard deviation is another $80 to the right and to the left. Well, by our empirical rule, see, I'll pull that up. If we look at our empirical rule, the main takeaway from the empirical rule is that within one standard deviation, either direction of the mean, we have 68% of our data, and that breaks down evenly to 34 on either side in one standard deviation. And that works because we have that symmetry going on with the normal distribution. If we go out 2 standard deviations, we'll have 95% of our data within 2 standard deviations in either direction. That adds on an extra 13.5% in each of these sections. And then furthermore, if you go 3 standard deviations out, you have 99.7% of your data. And so really, we just want to look at the percentages within each one of these deviations in order to solve the question at hand. So I'll put that back down and let's look at this question. What's the approximate percentage of buyers who paid between $9.20 and $10.80? Well, that's our mean is here at 1,000, so that's 1 standard deviation below, 1 standard deviation above. We check that chart real quick. We know that's 68% by the general rule here. I'll type in 68. And then we were looking at the percentage of buyers who paid between $7.60 and $1,000. Well, this is between the mean and the 3rd standard deviation below. So I go back to my chart, and I have 34 plus 13.5 plus 2.35. Let's see, that gives me 47.5, 49 point, let's see, what would that be? I just lost my train of thought for 1 second. 47.5 plus 2.35 gives me 47.85. Is that correct? I believe so. I'll double check that. Oh, 49.85. Okay. I lost the 2 on that one. Okay, the next question is, what's the approximate percentage of buyers who paid more than $12.40? So this is greater than 3 standard deviations. This is a really small portion of the data, and if we look at that off to the distance, that's 0.15% beyond the 3rd standard deviation. So this would be 0.15%. Now we're looking for the percentage between 840 and 1,000. That's between our mean and 2 standard deviations below. And that would be 34 plus 13.5. That was our 47.5. The next question is between 1,000 and 1080. Well, between 1 standard deviation either way, we had 68%. So if we divide that in half, we know we have 34% here. And then the approximate percentage of buyers who paid less than 840, that would be below 2 standard deviations from the mean. And if we look at that last one, oh, did not pop up for me. Hold on. Click on that. There we go. So below 2 standard deviations, we have 2.35 plus 0.15, which gives me an even 2.5. So I hope that helps out on this type of problem. Like I said, I think a lot of people were trying to use the normal distribution on your calculator, and that's when you have a specific value that's not laying straight on one of the standard deviations. The empirical rule gives us a nice way to estimate the percentage within exact standard deviations. Feel free to email or let me know if you have any questions or concerns.